Now let's see the detail about the label distribution and management. First is how to distribute the local label. For example, we have two modes. One is DOD, another one is DU. DOD is downstream on demand, right? And if now we have the topology route A and route 1, 2, 3, and we have two segments 10.1.1.0 and 20.0.0.0. Now, if we want to transfer the information from left to right, right? The packet is from left to right. So everyone must get the segment information of 20.0.0. Then we can help to force the message out. So the DOD means the upstream router sends the label request message. That means, for example, hi, my neighbor, can you give me some label information to the downstream router? Then the downstream router receives the request packets, and we will distribute the label to the FEC and send the label mapping message to upstream router and includes the label information. Then the upstream router will receive the message to make them to become the out label. Because on our label table, we have two parameters. One is in label, another one is out label. In label will be distributed by myself for local router. But how to get the out label? We must get this information from downstream router, right? So if we use the function of DOD, that means route 1 will send out the message, please give me the label for the 20.0.0.1. I will make this label to become out label. And then the route 2 also will send out the request message to route 3 because the route 3 is most downstream router. This is the first router to get the information of 20.0.0.1. Then route 3 will give the label mapping message. Hello, please use the label 3 as your out label, right? And the route 2 also will send out the local in label 36 to become out label for R1. So this is a function of the DOD. I will send out the request, then my neighbor will give us the label information. And another way is the DU function, downstream unsociated. That means after successful LDP session setup, we established the session successfully. Then the downstream router will directly send the label mapping information to upstream router without waiting for requests. That means, for example, R3 already established session with R2, and I will distribute the label 3 as in label, right, for the segment 20.0.0.1. And I don't wait any request from route 2. I will directly send the message to you. Hello, please use the label 3 as your out label, right? Maybe at the current, route 2 don't make the in label, but we already received the label mapping information from my neighbor R3. And about R2 also will directly send the label information to R1. Although maybe we don't receive any request message from R1. And another one for the label allocation, we also have two modes. One is the independent mode, and another one is ordered. In the independent mode means the local router will allocate the label to a route, includes the direct route or the other prefix. Once it has learned the root prefix using the IGP learning, okay, the local router will immediately send the label mapping information to the upstream router. And here also is one example. We have two user A and user B. And about the user A and user B, if they want to communicate with each other, all the router, route 1, 2, 3, all of them must get the label information. And route 3 is a bottom router for the segment 20.0.01. That means this is the most downstream router, right? And although if route 3 no label allocated for the 20.0.0.1, route 2 can allocate the label for 20.0.0.1 first. That means route 2 have the in label, right? Maybe about the in label, route 2 send to 36. And now the out label is empty. It's not. It's empty. That's because we don't receive any low label mapping information from route 3, right? Although the outer label is empty, but we still can immediately send the 36 to my neighbor R1. And R1 can get the label information. And then if we receive the message from user A, I will add the label for 36 and then forward to R2. But now maybe we don't have any outer interface, so the packet will be discarded. So this is a way for the independent control. I will directly send my in label to my neighbor without any out label. Okay, and another one is ordered control. That means only the bottom router on the route can directly allocate the label to according to the DO or maybe DOD label distribution rules. Then the upstream router, like the route 2, can send the label to my neighbor. Because if everyone can directly send the label mapping to your upstream router, according to the forwarding plan, maybe they don't have the correct path to forward the message out. So avoid this problem, we can change the mode for the ordered control. So in this mode, although the route 3 is a bottom router for the segment 20.0.0, then if route 3 doesn't have any label information to the neighbor R2, R2 cannot send out the label information for R1 until we receive the message from R3. That means your out label already have the number, maybe it's number 3. Then we can allocate the in label to my neighbor R1 to become the out label. So this is ordered control. And another one for the label retention, we have the liberal retention and another one for the conservative retention. And what's the difference? That means if you have multiple paths and you maybe will receive multiple labels for the same FEC, we retain everything or maybe only get the best path. This is a difference. If you return all labels from your neighbor, this belongs to the label retention. And the advantage is if the LSP convergence time is reduced in case of IP routing convergence and next new hop. For example, in this topology, about the route 3, we can send the distribute label to route 2, right? I will show you the label 3. You can take it to become the out label. And except route 3, we also have another neighbor for route 4. Route 2 also can use route 4 to wait the segment for 20.0.0.1. So I also will distribute one label for 100.0.1 to my neighbor. And if route 2 receive everything from all the router, we can get the information for the label 3 and also for the label 101. And then if one link is broken, for example, if this link is broken, this is the best path, right? And we can directly use the backup label 101 to wait the same destination. So if you use this way, that means your convergence time will be reduced. But the disadvantage is you need more resources, more space, more memory to install all the labels. So this is the library. And another one is a conservative retention. That means we only retain the best path. Who will be our best path? Who is our next hop router? And I only receive my next hop router's label information, right? I will distribute the label 3 to you and you will retain it. But if your another neighbor route 4 distributes the label 101 to you and we will reject it, we will discard it. So the advantage of this way is we reduce the usage of memory and label spaces, right? We only install one label for the best path. But the disadvantage is the LSP convergence is slow. If one link is broken, for example, if this link is broken, you have to wait your IP router convergence first. Then you have to establish the LDP session. And then you have to wait your neighbor send a new label to you, and then you can use the label to force a message out. Before the LSP convergence successfully, all the packets will be discarded. So this is the advantage and the disadvantage. And about the label space, we also have two types, per platform and per interface. And about the per platform means the label mapping message advertised by the local router take effect globally. That means the label advertised through different interfaces are the same for the FEC. For example, for the route 2, if we have two LDP stations, two LDP neighbors, route 1 and route 4. And then we will distribute the label for my neighbor, right? If the FEC is 20.0.0.1, although we have different neighbor, but we will use the same label to my neighbor. And this label will become outer label to in the label table. That means for route 2, the same FEC, we will use the same label. Although finally this label mapping information will be forwarded out through different interfaces. So this is a local space for per platform. And another one for the per interface. That means the label mapping message will be advertised by local router take effect partially. The labels of an FEC varies different on the interfaces. Also the same topology. And for the same FEC 20.0.0.1, if you have two interfaces to establish for different neighbors, we will use different label 100 and the label 200. This is the difference. And for the label actions, how to allocate the label, how to distribute the label, how to maintain the label, and for different interfaces, we use the same label or maybe different label. We have two types, right? And by default, the local actions in the frame mode is we will use independent control and downstream isolated and library ratings and per platform. So these are the actions by default we take it. And this is the part we explain how to distribute the label. And the most protocol we use is LDP. And in the LDP, we have lots of protocols. And we already know what is MPLS label, right? And how to distribute the label. The next part we will explain. If we already have the label table, then how to forward it. This belongs to the forwarding plan. About the forwarding process, if we already get the label table about all the router, how to forward the message. And in the forwarding plan, we have one concept we call is NHLFE. This is shorter for next hop label forwarding entry. And one forwarding entry contains the next hop information about the label of MPLS, includes who will be your next hop, right? Because you have to use the next hop to get the MAC address and then encapsulate the message successful. And also the data link layer encapsulation method, and also about the label stack coding methods, about operating on the date packet label stack. For example, if we receive the message, should we add the label or maybe swap the label or maybe delete the label? This is the option. And the incoming label maps every in label to multiple next hop. And the ILM instructor a router how to forward the label MPLS packets. That means the table includes all the entries. This table we call is incoming label map. And the FEC to the next hop maps every FEC to multiple next hop. Once the LAR receive a packet, if that is not labeled, that means you must to add the label information. And then you have to encapsulate the packet successfully, add the layer 2 information, like the source MAC address, destination MAC address, something like this. And finally, to make them to become the bit and enter into the table, then forward to the next hop. So this is a basic one. And then let's see one example to show you how to forward the message out. Okay, now let's see one example how to operate the message. And one action for the label is push. Push means if we receive the packet without any label, and then we have to add the label, and this action we call is push. And for example, like this topology, we have two routers, two users, user A and user B, and we have three routers located in the MPLS network. User A and user B located in the non-MPLS network, maybe it's IPv4. And now if the user A want to visit the destination 20.0.0.1, and we hope we can use MPLS to forward the message out. Let's see the process. First, the three routers must run the IGP protocol, like OSPF or ISIs, maybe static. Then we have to get the routing information. So on all the routing table for three routers, we have the segment for 20.0.0.1, and we also have the next hop. Then if we establish the LDP session in three routers, they will establish the LDP session and find the neighbor. And we will build the label forwarding table, LFIB. And in this table, we have lots of parameters. And the most important one is in label. And this in label function is used to match. If we receive some packets, includes the label, and we will take the label to match our in label list. And if we match this label, we will direct it to use out label or next hop to encapsulate the message immediately. And this is a function. And who will distribute the label for local router? That means every router will take the FEC, like 20.0.0.1, and we will distribute the label for this FEC. And this label will be added into the in-label list. So this is a function of in-label and who will distribute the in-label. And the next parameter is out-label. And the function for out-label is if we take the label information to match all the in-label lists. And finally, we found one entry is successful match. Then we will take the outer label to do encapsulate for the packets. And this is a function. And who will distribute the outer label? My downstream router, my neighbor. For example, neighbor 2 will take the in label into the LDP packets and then to my neighbor route 1. And route 1 will take the label to become the out label. So this is the distribution for the out label. And the next hope is we will have the outer interface, and we also have the next hope address to do the encapsulation. So this is a function. And then let's say the process. If now we want to distribute for the FEC 20.0.0.1, what's the process? First is route 3 is the most downstream router. That means if route 3 sends out the message to interface F0/1, we must to delete the label information because the next hope devices is the non-MPLS network. So we have to delete the label. And this router we call is most downstream router. So about the outer label will become none because you have to delete the label. And for the route 1, this is the most upstream router. This is the first router to connect with MPLS network. So we will receive the packets without any label information. So this will be none. And then all the router will distribute the in label for themselves. The route 3 will distribute the label 3. Because route 3 is the most downstream router, so we will give some special label for special label 3. Label 3 also indicates route 3 is the most downstream router. So you can directly delete the label 3 if you force the message out. And later we will show you the example. And then this label 3, we will take the label mapping packets to my neighbor R2, and the 3 will become the out label in the R2. And also R2 will distribute the in label for the FEC 20.0.0.1, for example, is 36. This in label will be distributed randomly. So maybe first time you see the label is 36, but next time maybe will become 46. And then this in label also will be distributed using the label mapping packets to become the out label. So this is a whole step. And this label only used for the routers to force a message from 10.0.0.1 to destination 20.0.0.1. If you want to give some replies, a message from 20.0.0.1 to 10.0.0.1, you also have to distribute the label for your FEC 10.0.0.1. You will have a new label information. So this is a process. Then we also will add who will become your next hope, right? And then let's say the following plan. If user A sends out the message, the destination IP is 20.0.0.1, the source is 10.0.0.1. And the first time the R1 will receive this IPv4 message, we will take the destination to match our IP routing table. And in your IP routing table, there is a feature will show you these packets already gives a connection with your MPLS label. So we will next step to match your MPLS forwarding table and find the out label. Then we will add the label 36. If you don't deploy the label information and don't distribute the label for this FEC, when you take the destination IP address to match your IP routing table, you will directly find your next hope and do the encapsulation and then forward the message out. So this is the first step for route 1, the most upstream router. We will do the action is label push. And for the next step, Now route 1 already sent out the message out of the interface F0/1 and takes the label is 36. Then we will, when the message sent out of route 2 will take the 36 to match all the LFIB table. And then we will find this entry is matched because every in label packet will be unique. And about the label, if we take the 36, then we will swap the packets. We will delete the 36 and add a new one for 3 because the out label is 3. So in this process, we will find route 2 takes the 36 to match all the in label. And because the in label is distributed by the route 2 itself, by myself, so I can keep every in label will be unique. But about the out label, this from my neighbor, we cannot control which label will be distributed by the other devices. So the out label will be different, but it doesn't matter. So we will add the label 3 and then to encapsulate the message. Then finally the message will be sent out to the next folder. So if you also have the other router like route 4, route 5, route 6, and they are the media router, so all the router will take the action for the label swap. And then the packets will be sent out to route 3, right? And route 3 will receive the message, and the message takes the in label for label 3. I also will take the label to match our in label for label 3. And then we will find the entry. This one, and the out label is none. None means you also have to send out the message to the Ethernet 0/1, but you have to delete the label 3 because now you connect with the IPv4 network. They don't recognize what means label. So this is the action for the label pop. And there are 3 main actions for the label. For first router, the most upstream router, you have to do the label push to add the label information. For the media router, like route 2, you have to swap the label to delete the in label and then to add a new label. And then for the most downstream router, like route 3, you have to do the action for the label pop. That's when you have to delete the label information and then send the origin IPv4 message to user B. So in this all the process, 3 routers for the message according to the label information. They will not to recognize your IP route table again. So these are the forwarding plan. About the next part, we will talk something about the MPLS configuration. If you want to use the MPLS function, how to add the configuration on all the network devices, then they will distribute the label and then they will forward the message according to the label information. The basic one is we already add the configuration on the network devices. For example, now if you have 2 routers, and they will have loopback address, and they also have the physical link to connect with each other. The basic is you must configure the IGP protocol or maybe static routing to ensure the routing reasonable. Because if you want to establish the LDP session, you must keep the TCP connection is ready. All the LDP session will be encapsulated into the TCP protocol. Then you have to enable the MPLS function, MPLS protocol. You have to enable the MPLS forwarding function global, and the command is MPLS IP. This is a typical command. Then you have to enable the LDP. Please pay attention. LDP and MPLS is different. MPLS, if you enable the forwarding function in the global, that means when you receive the MPLS packets, we can recognize. Otherwise, we will directly discard the package. And the function of LDP is help us to distribute the MPLS label and then to build label forwarding table. So this is the function of LDP. You also have to enable the LDP, MPLS router LDP, and tell the router who will be your route ID. And you can directly to use the interface loopback 0. So the route ID will become 9.9.9.9 for the first router. If you modify the loopback address, we will directly change the route ID. Okay, and we recognize the loopback interface and false attribute. That means it will take effect immediately to specify the LDP route ID. Because if you use a physical interface, if the interface is down, that means your LDP session will be broke. Then you have to enable the label switching on the interfaces. Enter the physical interface and then to enable the label switching. And by default, the layer 3 interface can identify only IP packets if label switching is disabled. Then if you receive some MPLS packets, the packets will be discarded. And you also have to enable the LDP on the interfaces. Enter the physical interface, MPLS IP. And then you can check some information. Because we already know LDP have lots of packets, right? How to find the neighbor, how to establish the session, how to distribute the label for the FEC. But this process, they will do with your neighbor automatically. You don't add to other configuration. So the configuration for MPLS is very easy. Enable MPLS. And enables LDP in global and also in your physical interfaces. Then you can check some information like show MPLS LDP parameters. You can find who will be your route ID and what's your control mode and what's the other like emergencies, the session protect, something like this. You can check your MPLS LDP. And also you can show your LDP discovery details. You can find who will be your neighbor, right? And this for the local LDP. And another one is what's your transport IP address, the session source address. And this also use your route ID. And another is LDP identified for 9.9.9.9. This is your neighbor. And you must keep your LDP session, the TCP connection is ready. And also you can check your neighbor information by the MPLS LDP neighbor. And here are all the neighbor information. Which port we use to establish the connection is 646, right? And who is your neighbor address is 9.9.9.9. In the LDP, running includes a neighbor discovery, find your neighbor, and then establishes the LDP session. And also you have to maintain the session. And we will use the TCP port number 646. And also when we find our neighbor, we will use the 646, but encapsulate into the UDP. And the special port number you have to know, if you add some policy in your network, you must allow the port number to pass through. And another, you also can check your MPLS LDP boundings. This one is very important. For your LDP, your FEC 1.1.1.0 and the other segments, you already distribute the label for the network devices. And the local bounding to LSI 9.9.9.9 because the 1.1.1 segment for myself, so the in label will become none. This is your first router. And something label for 9.9.9, you will have the in label 11264, and the out label is none because this is the most downstream router. And the LSR distribute label are valid locally. That means different router for different FEC or maybe for same FEC, they can use the same local label. It doesn't matter. And for the MPLS forwarding table, you can check the LFIB, and we have lots of operation for the labels, and we only explain for push, pop, and swap. But except them, we also have the other functions. For example, you can check for the local label, what's the out label. None means you have to delete the label, and what's the action pop, you means you have to delete the label. Push means you have to add the label. And what's your FEC for 9.9.9.9, and what's your outer interface, what's your next hop. And there are some questions. Which devices is responsible for pushing a label in an MPLS network? Who will do the action for the push? So option A is correct. The LER where the packet enters the MPLS network. This is the most upstream router, right? When we receive the message belong to the IPv4 network, and we will check the IP routing table, and about your IP routing table entry will connect with our MPLS forwarding table. Then we will add the label information. And all the LSI in the MPLS network, this is broken. And for the LER, the packets leave the MPLS network. That means we have to pop the label. And then the next question, how many bits does MPLS label have? How many bits does the label field has? The option B, the whole MPLS label, we have 32 bits. But about the label field, we only have 20 bits because we also have other field like the TTL, right? And like the EXP to provide the QS function. And another one for the label swap. Which of the following statements about the label swap on the LSI are correct? The answer is option A and option D. Once the package arrives, the LSI will match the packet's MPLS label with the in label, right? So this is correct. And another one for the change. First step, we have to match. The second step, we have to change. If we change, we will use the out label in the forwarding table. So this one is very important. The in label function is used to become match, and the out label is used to add a new label. So the option A and option D is correct. And about this course, we explain why we need MPLS, right? And what's the basic concept in the MPLS. And the other one is we explain the detail for the label and the label distribute protocol LDP. And the last step, we also give one example to show you how to forward the message according to the forwarding table, and also how to add some key configuration to run the MPLS. But the most advantage in this process, why we use MPLS? Because we can directly match the entry and then use the forwarding message to forward out successfully. Not like the IP forwarding table, we will use the longest prefix principle. So if we use the MPLS to forward the message, the speed will faster. But now, because our hardware devices because our hardware has high performance to forward the message out. So currently, why we use MPLS? Because we want to use the MPLS VPN feature. But if you want to know the MPLS VPN feature, this belongs to the other course. That's all about this course to expand MPLS network.